Ever pause to think about the journey a sleek, ultra-high-definition television makes before it lights up your living room? Every year, manufacturers around the globe turn out hundreds of millions of TVs, yet few people truly grasp the complexity and controversies hidden in each unit. From the raw glass that must be flawless to the whisper-thin components that power our favorite shows, it's a surprisingly high-stakes process. And once you dive deeper into the factories where these devices are made, you'll uncover a realm filled with cutting-edge technology, along with rumors, speculation, and even a few whispered secrets the industry doesn't want you to know. But how are these stunning screens brought to life? And what challenges lurk behind the streamlined facade we see on store shelves? Let's explore every layer of this intricate operation, revealing everything from the earliest stages of production to the final mile on a delivery truck, and the controversies that continue to shape the future of television. It all begins with the one part of a television that seems deceptively simple: the screen's glass. This giant sheet isn't just any standard pane from a hardware store. It's an ultra-clean, meticulously crafted panel formed from raw materials like silica sand and other specialized compounds. The process takes place in sterile, climate-controlled facilities because even a single grain of dust can cause tiny imperfections. One misstep could mean tossing out an entire batch of glass, costing manufacturers millions. This glass undergoes a series of transformations. It's heated, shaped, and cooled under conditions so precise that entire rooms are sealed off to prevent contamination. Since modern TVs are so razor-thin, the glass itself has to be both sturdy and flexible enough to handle the next stages of production without warping. It's an engineering feat that was unimaginable just a couple of decades ago. Some insiders even claim the yield rates, how much usable glass is successfully made, can vary greatly between competing factories, fueling unconfirmed rumors that certain brands discreetly purchase leftover glass panels from rivals when their own production falters. But that's only the starting point. Every minute step from here on out gets more complicated, layering science and skill in ways most viewers never consider when they power on their television at home. And the real surprises emerge once the liquid crystals enter the scene. For many people, the phrase liquid crystal display is just technical jargon. In reality, it represents a pivotal shift in how our screens look, feel, and function. Older cathode ray tube (CRT) televisions were heavy, boxy, and far from energy efficient. But with LCDs, the primary concept revolves around sandwiching a layer of liquid crystals between two thin sheets of precisely engineered glass. When an electric current passes through these crystals, they shift orientation, allowing or blocking light for each pixel. This mechanism gives you the brilliant range of colors we often take for granted. To make those colors pop even more, LED backlights were introduced. These are essentially tiny light-emitting diodes arranged in strips or clusters behind or around the screen, bathing those liquid crystals in a steady glow. With LED technology, screens became slimmer, energy consumption dropped, and picture quality soared. But are LCDs and LEDs really the pinnacle of TV displays? Some argue that OLED, organic light-emitting diode, is already overtaking LCD tech due to its ability to power each pixel independently for superior contrast. Others point to QLEDs, boasting quantum dots promise enhanced color and brightness. Whispers in R&D labs even suggest that micro-LED and mini-LED might be the ultimate next step, offering industry-defining clarity. Yet each new innovation brings its own set of controversies and rumors. Some worry about the chemicals used in quantum dot coatings, while others question the longevity of organic materials in OLEDs. Nonetheless, the mainstream success of LCD and LED technology paved the way for a manufacturing juggernaut. And if you think this is where the story ends, think again. Because every shiny LED or quantum dot is brought to life by a hyper-precise assembly line, an operation so meticulously choreographed that even the smallest glitch could topple a brand's reputation in an instant. Step onto the factory floor of a major television producer, and you'll be awestruck by the sheer scale. Vast lines stretch hundreds of meters, with parts moving in near-perfect harmony alongside conveyor belts, robotic arms, and a legion of human workers. Some factories can churn out a TV every few seconds, thanks to a synchronized dance of placing circuit boards, attaching screens, and fitting frames. Robots play a starring role here. They pick up fragile glass panels using specialized suction cups, positioning them carefully to avoid cracks. Then, in a blur of mechanical precision, they attach components like LED strips or optical films. Workers, too, move quickly, guiding motherboards or scanning parts for defects. While the process is largely automated, many subtle tasks, like fine alignment or certain quality checks, still rely on skilled hands and human oversight. With all that speed, it's no surprise that rumors spread about potential workforce challenges. Some claim that employees endure long hours under intense pressure to keep these production lines moving without delay. Others speculate that the continued rise of automation threatens job security. Factory representatives often dismiss these accounts as exaggerated, pointing to policies that ensure fair labor conditions. Yet the whispers persist. After all, a massive output of 500,000 smart TVs per year doesn't happen without formidable demands on both people and machines. But the real heart of a television isn't just its glass or its LED strips, it's the circuitry humming beneath that glossy exterior. And that's where we discover the brains running the show, fueling everything from your Netflix streams to your gaming marathons. If the screen is the face of your TV, then the circuit boards are undoubtedly its brain. Modern television sets rely on multiple boards to function seamlessly. Chief among them are the SSV, the main board, sometimes also called the motherboard, and the PSB, the power supply board. Together, these printed circuit boards govern picture quality, process signals, and enable internet connectivity, basically turning a hunk of glass and metal into the entertainment hub of your living room. Mounting the thousands of tiny components onto each board is a mind-boggling enterprise. From transistors and resistors to capacitors and specialized chips, every single piece must be placed with flawless precision. Automated machines known as pick-and-place handle most of the grunt work, pulling components off reels at lightning speed before soldering them onto the board. Each micropart must be oriented correctly. A mistake so small you'd need a microscope to see can cause the board to fail. But where do all these components come from? That's where supply chain speculation enters the picture. Some parts rely on rare earth metals, spurring concerns about environmental damage or questionable mining conditions in certain regions. Tech insiders whisper about certain factories having priority deals for critical materials, which can lead to inconsistent pricing or last-minute shortages. In extreme cases, entire production lines can grind to a halt if a key component is delayed. Yet despite these complications, most of us never notice. We press the power button, and our screens spring to life, quickly, seamlessly. We rarely question just how much back-and-forth negotiation and strategy goes into ensuring those boards are fully stocked and assembled. And that's not even mentioning the rigorous testing these boards must pass before they're cleared for mass distribution. Bringing together glass panels, LED backlights, and circuit boards results in something that looks like a television, but it's not truly ready for the spotlight until it survives a gauntlet of tests. Quality control is make or break for manufacturers, since a single defective batch can cripple a brand's reputation. In some factories, brand new sets are lined up in rows under the glow of specialized testing lamps, while technicians run color bar tests, measure brightness uniformity, and ensure the pixels align perfectly. High-resolution scanners examine the surface to catch tiny flaws invisible to the naked eye. In advanced facilities, these inspections go beyond simple visual checks. Automated cameras cycle through color patterns, analyzing any irregularities that might indicate stuck or dead pixels. Similarly, stress tests simulate hours, sometimes days, of continuous usage to verify that the device won't overheat or malfunction when placed in a real-world living room. Despite these exhaustive protocols, there are still murmurs that some companies occasionally rush their testing phase to boost output. Could that compromise quality? It's difficult to say for sure, but consumer forums are filled with anecdotal reports of people who purchased a brand new set only to discover backlight bleed or flickering issues. Manufacturers typically dismiss these claims, chalking them up to shipping damage or a rare factory defect. Still, as TV technology grows more complex, ensuring perfection every single time becomes an increasingly daunting task. But even after a TV passes its tests and powers on flawlessly, there's one last chapter in its journey: the packaging and shipping phase, where televisions risk damage and other challenges before they ever reach your home. A massive television boasting a 65-inch or larger screen demands careful handling. Once the final inspection is done, workers or robotic arms lift each set onto a packaging line. Protective materials, foam inserts, plastic wraps, and corner guards are used to shield the screen from shocks and scratches. The last thing a manufacturer wants is for a consumer to open the box and discover a cracked display. From there, it's onto pallets and into trucks, ships, or planes. Tens of thousands of these boxed TVs crisscross the globe each day, heading to warehouses and retail outlets. Some brands tout their green packaging solutions, emphasizing recycled materials or reduced plastic usage to address environmental concerns. But critics question whether such steps truly offset the gigantic carbon footprint involved in transporting these electronics worldwide. Logistical nightmares sometimes crop up. Storms or border delays can hold up shipments, while mishandled freight can result in entire pallets of TVs being destroyed. Additionally, shipping rates and fuel costs fluctuate, impacting a manufacturer's bottom line. Retailers often negotiate for the best deals, leading to behind closed doors bargaining that can shape whether your favorite model stays in stock or mysteriously vanishes from store shelves. Still, for most of us, the next time we see that television is in a flashy electronics store or delivered straight to our front door. And at that moment, we rarely think about the epic journey behind it, or the controversies that swirl beneath the surface. For the average consumer, turning on a new television is a moment of excitement. But behind that glow, the industry grapples with controversies that range from environmental issues to corporate intrigue. One major concern is e-waste. As new models flood the market, older sets often end up in landfills or scrap heaps. Recycling programs exist, yet the sheer volume of discarded electronics continues to worry environmental groups. Some accuse manufacturers of planned obsolescence, suggesting that software updates or design changes subtly push consumers to upgrade sooner rather than later. Then there's the competition between big-name brands. Rumors occasionally surface about clandestine deals or even sabotage attempts, where one brand might buy up vital components to delay a competitor's production run. These stories can be hard to confirm, but industry insiders insist that the battle for market dominance is fierce. Meanwhile, certain factories face allegations of labor violations or employing cost-cutting measures that might compromise worker safety. Although official statements often deny such claims, the rumors persist, hinting at conflicts deeper than any sleek marketing campaign reveals. It doesn't stop there. Some TV makers are under scrutiny for data collection practices. Smart televisions that connect to the internet can track viewing habits. While these features often aim to improve content recommendations, critics argue that it's a privacy minefield, especially if companies share or sell user data. As the industry marches forward, controversies like these shape everything from how TVs are built to how they're advertised and sold. And for those paying attention, it raises a bigger question. In the race to produce more units at lower costs, might crucial ethical and environmental considerations be getting sidelined? Despite the controversies, the television industry continues to thrive and evolve. After all, TV sets aren't just for news or entertainment anymore. They're becoming multifunctional portals into our digital lives. One corner of the market is gravitating toward ever larger displays, pushing 85-inch models and beyond into mainstream availability. Another corner focuses on resolution wars, jumping from 4K to 8K, and even whispers of 16K or beyond 8K formats in the pipeline. Meanwhile, flexible and rollable displays, once dismissed as science fiction, are inching closer to reality. Some experts predict that within a decade, we might hang paper-thin screens on walls, or even unroll them like posters. Micro-LED technology, considered by some to be the holy grail of display tech, promises near infinite contrast, incredible brightness, and no risk of burn-in. However, industry chatter warns that manufacturing micro-LEDs in large, affordable panels is far more complex than marketing slogans suggest. Beyond hardware, the very idea of what a television is could be changing. Companies are experimenting with integrated smart home hubs, voice-activated controls, and augmented or virtual reality add-ons. In certain labs, prototypes are merging screen technology with wearable devices, raising the possibility of immersing ourselves in content in ways unimaginable just a few years ago. Whether these innovations will redefine the living room remains to be seen. But there's no doubt the TV of tomorrow will be more than just a rectangular panel on a stand. From raw silica transformed into pristine sheets of glass, to the mesmerizing dance of liquid crystals under LED lights, each television you see on store shelves has undergone an astonishing and sometimes tumultuous journey. Factories carefully balance high-speed production with painstaking quality checks, all while juggling supply chain demands and the ceaseless quest for technological advancements. Rumors of shady negotiations, heated brand rivalries, and questions about sustainability underscore that this isn't merely an industry of bright screens and sleek exteriors. It's a world brimming with hidden complexities. Yet, despite controversies over e-waste, labor conditions, and corporate power struggles, the push toward innovation shows no signs of stopping. New breakthroughs in display technology promise ever sharper images, bolder colors, and interactive capabilities that might transform how we experience media altogether. The next time you settle in to watch a blockbuster movie or the latest viral series, take a moment to remember the million-square-meter factories, the microscopic precision of circuit board assembly, and the countless hands, human and robotic, that brought that screen to life. And as the industry charges forward, the story behind every television only grows richer, fueled by both the drive for profit and the spark of scientific curiosity. Where will the next wave of inventions lead us? That's a question only time can answer. But one thing's certain, the screen glowing before us now holds more secrets and potential than we ever imagined. Thank you for joining this deep dive into the intricate, fast-paced realm of TV manufacturing. If you found it fascinating, consider sharing this story with fellow tech enthusiasts. After all, the screens we rely on every day have a story worth uncovering, and that story is far from over.